Your eyes have no blue in them, not one drop of pigment. What you're looking at in the mirror is a trick of physics, and the very first human it happened to had skin so dark it would look almost black to us today. Every blue-eyed person walking around right now, all of them trace back to that one ancestor. Same mutation, same tiny stretch of DNA, one glitch copied billions of times over. For nearly all of human history, that glitch didn't exist. 300,000 years of humans, and every single one had brown eyes, no exceptions. Out on the open plains of Africa, the sun wasn't gentle, it was relentless, and it did real damage, burning skin, breaking down nutrients the body needed for healthy pregnancies, and quietly wrecking the delicate tissue of the eye itself. The body's answer was melanin, a pigment that soaks up ultraviolet light before it can do harm. A gene called OCA2 ran that whole operation, pumping out melanin nonstop, filling every iris with a thick protective layer of brown. It worked for tens of thousands of years across wildly different landscapes, from savanna to forest to tundra. And when something works that well for that long, evolution has no reason to touch it. Then, sometime between 6,000 and 10,000 years ago, somewhere around the Black Sea, it broke, not gradually, instantly, in one birth. A 2008 study out of the University of Copenhagen traced the origin by comparing DNA from blue-eyed people across Denmark, Jordan, and Turkey, and found something strange. Every one of them carried the identical mutation at the identical spot. Not similar, identical. That kind of match doesn't happen twice by chance, it happens once, in one person, and spreads. The mutation didn't hit the OCA2 gene directly. It hit a neighboring switch called HERC2, which controls how much OCA2 actually gets used. The precise mechanics of how are still argued over by geneticists. It didn't shut the factory down completely, which would have caused albinism. It just dimmed it, and only in the iris, diluting the brown until the eye was left with almost no pigment at all. What you see as blue isn't color. It's light scattering off empty collagen tissue, the identical scattering effect that turns a clear sky blue. No pigment required up there either. No pigment. Just structure. Here's where it gets stranger. We used to assume the first blue-eyed people were pale, blonde, Scandinavian, the modern stereotype. Ancient DNA says otherwise. In 2014, researchers sequenced the genome of a 7,000-year-old skeleton found in a Spanish cave. A hunter-gatherer nicknamed Labrañawan, dark skin, dark, curly hair, and the HERC2 mutation for blue eyes. Around the same time, a nearly identical genetic profile turned up in Cheddarman, a roughly 10,000-year-old skeleton from England. Dark skin, blue eyes, that combination, not pale skin, and blue eyes, was the normal look for early Europeans for thousands of years, long before anyone in the region looked anything like the modern stereotype of a Scandinavian. Pale skin came later, and for a completely different reason: farming. Around 10,000 years ago, agriculture spread out of the Near East and into Europe, bringing grain-heavy diets that were cheap in calories but almost empty of vitamin D. Combine that with Europe's weak winter sunlight, and dark-skinned farmers started developing bone disease from vitamin D deficiency. Lighter skin let in more of the scarce sunlight, so it spread fast, a real survival advantage. Blue eyes had already been around for thousands of years by that point, evolving on a completely separate genetic track from skin color entirely, which leaves a real puzzle. We know exactly why pale skin spread it kept people alive. Blue eyes offer nothing like that. They let in more glare, protect less from sun damage, and give zero advantage for hunting or fighting. Yet the mutation went from one person to hundreds of millions. Scientists don't have a single confirmed answer, only competing theories, and it's worth being upfront that none of them has been proven outright. One is sexual selection. In a small band where everyone has brown eyes, an unusual trait that catches the eye might simply get preferred as a mate more often, and a trait that helps you get chosen spreads regardless of survival value. Another is genetic hitchhiking. The HERC2 mutation sits close on chromosome 15 to genes involved in skin tone changes, so it may have simply ridden along as those genes swept through the population. A third idea points to trust. Pale irises make the pupil far easier to read, and in small, high-stakes groups, being easy to read may have made someone easier to trust, and trusted people get protected. And a fourth is simple luck, the founder effect, where the genes carried by the first handful of settlers into a new region end up written into every descendant that follows, regardless of whether those genes offered any edge at all. The fingerprint of that history is still visible today. Around the Baltic, in Estonia and Finland, light eyes are close to universal brown is the rare one there now. A complete flip of the ancient default. Move south toward the Mediterranean, and the numbers fall off fast. It's a map of ancient migration written directly into people's faces. You can even watch a small echo of that history happen in real time. Newborns in Europe and North America are often born with blue-gray eyes that darken over their first year, as slow-waking melanin cells finally start filling the iris, the same nervous guessing game every new parent plays, checking the crib for a color that might not be final yet, unless that HERC2 switch keeps it dimmed for good. So look back at the mirror. What's staring back probably isn't proof of clean, purposeful design. We still can't say for certain which theory is right. It's most likely the opposite, a chance error from one prehistoric birth with no clear reason it should have spread at all, now living in the eyes of hundreds of millions of people who will never know that ancestor's name.